But the main question is how the main shaft turns. So if the bevel gear and the clutch in the base turn separately, and the clutch in the base that actually turns the main shaft, but how does the engine turns the main shaft? In fact, the engine will turn the bevel gear. The engine will turn the bevel wheel, but those two rotate separately. So when the engine will turn this, so the clutch in the base will not turn, so my shaft will not turn. So this can be explained here. In fact, my engine will turn the bevel gear. That's it here. My engine will actually turn the bevel gear. But the bevel gear is completely separate with the clutch in the base. So as the bevel gear turn, the clutch in the base will not turn. So how will my engine makes my inner shaft move, makes the inner clutch base move? How do we do this? So this is why we actually use a friction plate. So how does this work? So the friction plate will be fitted on the pegs of the clutch base. So as you can clearly see here, I will show it again. So the clutch base actually has 3 pegs. Those are the clutch base pegs. In fact, the friction plate will be fitted onto those pegs. The clutch base will be fitted onto those pegs. So what will happen is that my engine will turn the bevel gear. But my bevel gear and my clutch in the base are completely separate. So my bevel gear will not turn my clutch in the base. So the thing that will happen is like this friction plate will be pressed on those friction material. This friction plate will be pressed on those friction material. When this friction plate will be pressed on those friction material, so as this turns, and if this is pressed against those friction material, as this turns, the friction plate will also turn. When the friction plate will turn, as the friction plate is fitted onto the pegs of the clutch base assembly, so the thing that will happen is that as the friction plate turns, the clutch base will also turn. As the clutch base is directly locked on the main shaft with a flat key, the main shaft will turn. As the main shaft will turn, this will turn the sprocket, as the sprocket is directly locked on the main shaft. As the sprocket turns, the bicycle wheel will turn. So we actually use a friction plate to turn the clutch in the base to be able to turn the main shaft. So that's it. So this can be explained on the diagram here. So my engine will turn the bevel gear, but the bevel gear will definitely not, but the bevel gear will not turn the clutch in the base, as the bevel gear and the clutch in the base are two separate things. So the thing that will happen is that I will have the friction plate, which is here. The friction plate, which is here, is fitted on the pegs of the clutch in the base. The clutch in the base is connected to the main shaft. So when the friction plate is pressed on the bevel gear, who has friction material on it, as the bevel gear turns, this will make the friction plate moves. This will make the friction plate move. As the friction plate moves, the clutch in a base will turn along with it, as the friction plate is fitted on the inner base with onto those pegs. So as the bevel gear turns, the friction plate turns. As the friction plate turns, the clutch in a base turns, as the clutch in a base turns, the main shaft also turns, and this will turn my sprocket, which will in turn turns my wheel. So now, before going to those part here, so the inner shaft and the flower nut, we'll be going through those different parts here, and to be able to explain this part. So let's do it. So let's do it. A quick recap. So I have the main shaft here. The particularities of the main shaft is that you'll be having a bigger hole, which is there in red, a bigger hole which is there. So you can check out those this assembly on BikeBerry. They made a quite good video on that. So you'll having the main shaft, you're having a big hole out here, and the main shaft will have a flat key. Will have a small race so that a flat key can fit into this, and it will be having this small race on both sides, so here and here. So the sprocket will be locked on the main shaft with the flat key. Again, here the clutch in the base will be locked on the main shaft with the use of the flat key here. Again, here another particularity of the main shaft is that it will be threaded on this side and this side. So why it is threaded on both sides? So I'll be using a nut and a washer. The nut and the washer will be screwed on the main shaft, on this part, on the threaded part here, so that the clutch in the base can be secured on the main shaft. Again, here the sprocket can be secured on the main shaft. So that's the first part. The second part is that I will be having a smaller inner shaft which goes inside the main shaft. So a small inner shaft which goes inside the main shaft. In fact, it is called the small inner shaft here is called the push pin or the clutch pin mandrel. So it goes inside the main shaft. So I will show you. So that's the main shaft, as you can clearly see here. That's the main shaft here, and that's the main shaft. There is another inner shaft that goes inside the main shaft. There is another small shaft that goes inside the main shaft. It is called the push pin or the clutch pin mandrel. So what are the particularities of this small inner shaft? The particularities are that, first of all, it will be having a small hole into it. So as I told you, the main shaft will have a big hole in red. The clutch pin mandrel or the push pin will have a smaller hole in it. So a smaller hole, so that in the size of a pin. So it will have a smaller hole in it, and it will be threaded at one side. So you can clearly see here that this is the main shaft. I have the inner shaft which goes in here, and it is threaded at this spot. Small inner shaft is like threaded at this spot. So you can clearly see this. It is threaded at this spot. So I'll be having the main shaft. I'll be having a smaller inner shaft that goes through the main shaft, and then I'll be having a collar here. In fact, the name is, so in fact they are called collars. I will be having collar here, C-O-L-L-A-R, or this is a ferrule. So this will fit onto the main shaft. So I have a main shaft. I have an inner shaft, a clutch pin mandrel, which goes in through the main shaft, and I'll be having a collar that goes over the main shaft. So I will show you this. So this is the collar. So this is the collar, or simply the ferrule. So as you can clearly see here, it goes over the main shaft. So that's it here. The particularities of the ferrule is that it will also have a small hole in it. So that's it here. So the main shaft has a big hole in it. The smaller shaft that goes through the main shaft has a small hole in it, and the cooler that goes over the main shaft has a smaller hole in it. So you're understanding. I can show you. I don't know if I will be able to show you this. So you can clearly see here. Small hole is here. So the main shaft has a big hole. You can clearly see, in fact, you can clearly see here the big hole. So extend here. There is a big hole on the main shaft. I think it is like this. There's a big hole on the main shaft. The smaller shaft has a smaller hole in it, and the cooler has a smaller hole in it. Same size as the inner shaft hole. So then what will happen is that there will be a pin that will be going through the ferrule, the cooler. There will be a pin that will be going through the small hole of the cooler, and the pin will go through the small hole of the cooler. It will go through the bigger hole of the main shaft, and will go through the smaller hole of the inner shaft or the clutch pin mandrel. So the pin will go through all of those three components. So the cooler, the main shaft, and the inner shaft. And the thing is that when the pin will go through all of those three components, they will be connected together. So what will happen is that, for example, if I take the color, I move the color. So what will happen? If I move the color, it's like, so for example, maybe on here, so forget about this spring, forget about this. So I have only this color, and I have a pin that goes through this color, the main shaft, the big hole of the main shaft, and the smaller hole of the inner shaft. So the pin goes through all of those three. So the pin goes through there. You understand what I'm talking about? So the big hole of the main shaft, it's like hole on both sides. I have the bigger hole in the main shaft. I have a hole here, and I have a hole also here. So similar for the cooler. So I have a hole on this side. I will be having a hole on the other side. So you understand. So the pin goes through all of those three components. So if I take the color, forget about those. If I take the color, I move the color, move the ferrule. So the pin will also move. So I move the ferrule. It will be having a maximum position here. So this maximum position is there because of the bigger hole present on the main shaft. So I move this, then it will hit against the maximum point on the main shaft, and then I can move it backwards. It will hit against the extremity of the bigger hole on the main shaft. So you understand. So if I move the collar, I can actually move the inner shaft. So why this movement? We have this movement because of the bigger hole on the main shaft. So again here, if I take this, I take this, I push it forward. The thing is that the pin goes through this and goes through this. The pin will go here and will hit against here. So this will be the maximum point here. So if I take the color, I shift it on the left. So the inner shaft, the push pin, will be shifted towards the left. So if I take the inner hole, I shift it toward the right. The maximum position will be here, as it will hit this end here, on the bigger hole of the main shaft. So the push pin, the clutch pin mandrel, will be shifted to the right. So that's it. So then we have a spring and another collar, or it is called the adjustment nut. So first of all, so I will show it. I will show you the part here. So I will be having the ferrule, the collar. So there is a pin that goes through all of the three. In fact, the pin enters here and goes out. I'll say here. So you go through all of the three components. So the thing is that I'll be having my ferrule, my collar here. I will place a spring here. So forget about this. I will place a spring here. So when I will place a spring here, the first thing that a spring will do here is that it will hold the pin in place. So I'll be having this, the one side of the pin which is here. So it will prevent the pin from going out. So the spring will hold the pin in place at this side, and on the other side also, the spring will hold the pin in place. But then we'll be including an adjustment nut which is here. So another particularity of the main shaft is that the main shaft has a threaded part over here. So this adjustment nut can be screwed on the main shaft. So this is very easy to understand. When I screw this adjustment nut, this will compress the spring more, or when I unscrew it, there will be less compression on the spring. In fact, as you can clearly see here, so this is my collar here. So as you already know that if I move the collar, I can move the inner shaft. But the thing is that if I place a spring onto this here, so the spring actually goes over the main shaft, like on this, the spring goes over the main shaft. So if I place a spring here, the spring first of all will hold the pin in place on both sides, and spring will also press on this collar. So as you can clearly see here, so the spring is actually pressing on this collar here. So when this is screwed, the spring is compressed. The spring actually presses on this collar. When actually press on this collar, the things that the clutch pin mandrel, or the push pin, the inner shaft, which meaning the inner shaft, will be always shifted on the right. So the pin will be at the minimum position. It will hit here at the minimum position of the hole. So it will stay here. So to sum up, so have this collar. So there is a spring here. In fact, I have an adjustment nut here. When I screw this will compress the spring. In fact, the spring apply force on this collar, this ferrule. As this ferrule is connected to all of the three components, the pin goes through this ferrule, which goes through the main shaft, which goes through the inner shaft. So when I'll be exerting force on this collar, so this will tend to move the inner shaft to the right. So when it will move the inner shaft to the right, it will hit against this minimum position here. So the inner shaft will be held to the right. So that's it. So the thing is that, and I will be having a cam actuator that when the cam turns, it will push on the inner shaft, or the push pin, or the clutch pin mandrel. So anyway, so it will, when I will turn the cam, it will push on the inner shaft. But as the inner shaft is connected to the collar through the pin, so when I will be pressing on that inner shaft, it will have the tendency to compress the spring. So you understand, it will have the tendency to compress the spring. So when the cam turns, the cam will have the tendency to move the inner shaft to the left. When the inner shaft will have the tendency to move to the left, as there is a pin that goes through all of those three components. So when the inner shaft moves to the left, the collar, this ferrule, will also move to the left. So in fact, the maximum position that it can move to the left is this maximum point here. So when the inner shaft will move to the left, it will have the tendency to compress the spring. So that's it. When I actually move the camshaft here, this will press on the inner shaft here, and the inner shaft will move towards the left there, and it will have the tendency to compress the spring, and the spring will eventually push the inner shaft in place when force is not applied on the camshaft, when no rotation is provided to the camshaft. So that's it here. But something to bear in mind is that the more you screw the adjustment nut, the greater the compression on the spring, the greater the tension on the spring, the more difficult it will be to shift the inner shaft towards the left. Systems for motorcycles, we usually use rack and pinion systems. But for this motorized bicycle, I'm using like a lever actuator, which is connected to a cam. So when this is pulled by a cable, so this will turn the camshaft. The camshaft will have the tendency to push the inner shaft. So that's it. So you can check this out. This is my clutch lever, which is found on my bicycle. So when I'll be pressing on that, this will pull the cable. The cable will literally turn the lever. So the lever is directly connected to the camshaft. So the camshaft will also turn. So literally, so maybe, for example, this is the camshaft. Suppose that it turns like in a clockwise direction. So I don't know, I'm only supposing. So this will push on the inner shaft. But the thing is that as the pin goes through the inner shaft and goes through the collar, there will be a strong opposing force of the spring, which will make the inner shaft have the tendency to go towards the right. So as long as I'm pressing on the clutch lever, so the camshaft will rotate. So the inner shaft will held in position, so I will shift towards the left and held in position. As soon as I remove my hand on the lever, there is a strong opposing force of the spring. So the spring will tend to return the inner shaft to its place. So in fact, the camshaft will be in this position. You see that the camshaft will be in this position here. And I will explain why this is threaded here. I will explain this part in a moment. So as I told you, the camshaft will be placed here. The camshaft is usually placed here as in the picture. The camshaft is here. Here the sprocket is locked here. So what will the camshaft do? The camshaft will have the tendency to push on the push pin. The camshaft will have the tendency to push on the push pin. But the thing is that there are some more parts for this to function. So as you can clearly see here, we literally have a hole here. So the camshaft will not be able to actuate, to press on the inner shaft directly. So this is why we have a bucking bar and a ball bearing. So the camshaft will be pressed on the bucking bar, and the bucking bar will press against the ball bearing. So this will in turn press against the inner shaft or the clutch pin mandrel. In fact, why using ball bearing and so on? So what's the reason? We need to understand that when our bicycle is moving, when the engine is turning the wheel of the bicycle, you need to understand that the main shaft is moving. When the main shaft is moving, the things that the inner shaft, as the pin goes through the collar and the inner shaft, the pin goes through all of the three components. So when the main shaft is rotating, the inner shaft is also rotating. So if I'm going to use only a bucking bar, there will be some kind of friction. So this is why I use a ball bearing. I use a bucking bar and a ball bearing. So place the bucking bar there and a ball bearing. The camshaft acts on the bucking bar, and the bucking bar presses on the ball bearing, so which in turn press on the inner shaft. So first way to identify where does the sprocket enter is that you already understand that where the sprocket is, you'll be having a bucking bar and a ball bearing. So where the sprocket is, you'll be having like a you'll be having a hole. You understand? Where the sprocket is, you'll be having a hole. So that's it. This is like a way to remember where does the sprocket fit. So when you have already put the spring in place, when you have already put this collar and this collar actually acts as an adjustment nut. This collar actually goes on the main shaft and screws on the main shaft. So in a sense, you'll be having a hollow tube where the sprocket will fit in. You'll be having a hollow tube, like there will be a hole. So when even the inner shaft will be automatically shifted to its extreme right by the spring, so you will be still having a hole here, and you'll be still having this bit like protruding out here, this threaded part protruding out here. So a way to remember where to put the sprocket is like there will be, when all those things are in place, there will still be a hole here, like a hollow tube here, where the bucking bar and the ball bearing will enter here, and you'll be definitely having a small part protruding out there, a small threaded part. So why do we have that small threaded protruding part of the inner shaft? Why do we have this? So why do we have this? So we'll try to explain this. So first of all, let's do a recap. So you'll understand that my engine will turn the bevel gear on which I have friction material, and the bevel gear, the wheel, and the clutch in the base are two separate things. So when my engine turns my bevel gear, my clutch in the base will not turn, so my shaft will not turn. But the thing is that I have a friction plate here. When the friction plate is pressed against that bevel gear, so when this will turn, this will cause the friction plate to turn. But the friction plate is held on the clutch in the base onto those pegs. So when this will turn, and if they are pressed firmly together, the friction plate will turn. When the friction plate will turn, the main shaft will turn. But the problem is that the friction plate holds loose onto those pegs. As you can clearly see here, that's the friction plate. So my engine will turn this part, as you can clearly see here as I turn this part. So this goes no rotation on the clutch inner base, and in fact that's the clutch inner base that will turn my main shaft, which will in turn turns my wheel. So if my engine is turning this, and while my engine is turning this bevel gear, this will not turn the clutch inner base. So what do? I will need to use a friction plate. I'll need to use a friction plate. So again here, when my engine is turning the the friction plate. When my engine is turning the bevel gear, again here, this is not turning my clutch in a base. So for my clutch in a base to turn, the friction plate needs to press firmly onto that bevel gear, onto the friction material on the bevel gear. But the thing is that the friction plate holds loose onto that. So you understand? So when I'm turning the bevel gear, so if this holds loose, so this will definitely not turn my clutch in a base, which will not turn my main shaft. So I definitely need to apply pressure on that friction plate. So when applying pressure on that friction plate, you see the turn, both of them turn simultaneously. So there, I need to apply pressure on the friction plate. But how this is done? This is simply done by a flower nut. This is simply done by a flower nut. So I'll take the flower nut. The flower nut will be screwed on the threaded part, on the threaded protruding part of the inner shaft or the clutch pin mandrel. So when I will screw the flower nut, this will apply a force on the friction plate. You understand? When I will screw this holds loose into that pegs. As you can clearly see here, the friction plate slides onto that peg. The friction plate only slides onto those pegs. So when I will be turning, when this will be screwed, so definitely this will press against the friction plate, and definitely my friction plate will press against the bevel gear. So which will, as I have friction material on the bevel gear, so when the bevel gear will turn, as this and this are like closely stick together, so the friction plate will have the tendency to turn. When it will turn, my clutch in the base will turn and my shaft will turn. So that's the use of that protruding threaded part. That's the use of the flower nut. But I will be having a spring in between. So when I'll screw this, it will compress the spring and will press the friction plate against that bevel gear. So definitely when I turn the cam, this will press against the inner shaft. When the inner shaft will be shifted towards the left, the thing is that this will move towards the left. When this will move towards the left, the spring will push on the friction plate, and the friction plate and the bevel gear will disengage. So that's the system. That's how the clutch works. That's how the clutch works. So that's it. So that's it. So how can I show you this? So basically the spring will go here, and basically this will go here, and basically the flower nut will press on that friction plate, and basically when the cam is turned, so this will shift the flower nut a little bit upward, so this will give a little bit more space, so the friction plate will move up, so the friction plate and the bevel gear will disengage. So that's the principle.